Hello and good afternoon. Thank you for joining. I think we still see people coming in, but we are getting started with our webinar today. So once again, thank you very much for joining. We're going to talk today about how predictive maintenance helps you to deliver great service, how you can benefit from it, and how you can implement it in your organization. My name is Matthias Lübko. I'm CEO of Fieldcode. We are producing field service management software, and today we're following the agenda to talk about a definition. What is predictive maintenance in the first place? We're going to talk about its benefits to an organization and how it can be implemented. We have also dedicated some time for your questions at the end of the session, so feel free to raise them in the chat during the presentation. We will collect them, mark them, and then go through all the questions at the end of the session. So let's get started with a definition of what is predictive maintenance in the first place. Predictive maintenance refers to the use of any kind of hardware, software, or service components to provide predictive analytics for mechanical assets or infrastructure maintenance. Predictive maintenance is used to monitor emerging failures. It is there to identify expected failure points and potential breakdowns, and it is there to determine remaining asset lifetime. Predictive maintenance provides the opportunity to take care of issues before they even occur. Meaning sensor devices supply data in real time, constantly, in order to predict when maintenance is required and to prevent equipment failure. This data is then used for analytics and for prediction. According to the Wall Street Journal, unplanned downtime costs industrial manufacturers an estimated $50 billion annually, and equipment failure is the cause of 42% of this unplanned downtime. Unplanned outages result in excessive maintenance. They result in repair and equipment replacement, which is very costly. In its essence, predictive maintenance refers to the use of data-driven, proactive maintenance methods that are designed to analyze condition of an equipment and help to predict when maintenance should be performed. This allows manufacturers and service companies to move from a repair and replace model to a predict and fix maintenance model using predictive analysis. In comparison to other service types, predictive maintenance provides the highest value, as the maintenance is only carried out when it is required, when it actually is needed for the device. It provides, with that approach, the golden middle way between a preventive and a reactive approach. So what do we consider in preventive maintenance? Preventive maintenance is based on a given timeline, given a certain usage, where after this certain time frame or use frame, a maintenance is carried out. It's not carried out earlier because it will cost additional money. It shouldn't be carried out later, as it may feed into breakdown. Reactive service models may be useful in a not critical environment, but they are very simple. Something breaks, you're going to go there and you're going to fix it. This is what is common and what is usual out there in the field. With predictive maintenance, you can, according to Gartner, you can save between 15 to 30% of cost in comparison to preventive service model. That is a quite significant saving you can achieve with a model which only is carried out when it is relevant. The success of predictive maintenance depends on three main components. First of all, you need to collect the right data. You need to collect the relevant data in a sufficient amount with the right quality. If you have this data available, you can evaluate it. You can make sure, you need to make sure that you interpret it in the right context. For example, if you do a measurement about temperature, the temperature might drop, which could simply mean someone opened the window. In an elevator environment, an elevator could be slow, which could mean it is just heavily loaded. So very often you can't rely on just one sensor only, on one input only, but you need to gain actual insights by putting multiple results next to each other and comparing. In the example of temperature drop, was maybe the window opened. You have another sensor which takes care about the open and close status of a window. You need to view data over time, and machines can take out of this context when do they need to take action. In addition to the data collection and data transmission, you need to act appropriately. Ideally, a system then automatically sends this ticket, sends this intervention to the correct engineer or subcontractor, however your service model works, depending on the issues found, depending on the outcome of the data which you have collected and analyzed. Let's look at some industry examples, starting with printers. Printers use already for a long time built-in sensors which can detect malfunctions, which can request service. Very simple. Toner may be going to an end. You need a replacement of a toner, which is not only relying on the pages printed, it relies as well on the information. Okay, how full is the toner? How high or low is the toner level? Because on a page you could print a lot, or you could just print little text, and depending on that, the machine will let you know when it needs an interaction. Another sector I already mentioned, elevator industry. Detection of any speed anomalies on an elevator can indicate an upcoming failure. Taking into consideration, if you see constantly speeds being off, if you see constantly that it doesn't move within the limits, could already lead to an early maintenance because it is still operative, and you don't want to wait until it gets stuck, until it breaks down, because then you may end up in an emergency situation. You want to take care about it at the time you see something is off the regular values. Another example could be in electrical panels. You want to prevent component failures, and you can capture that by temperature measurements. If the temperature rises, you see something is off, something is not in the limits, and you need to take action. This can happen fully automated. This can happen completely independent without anybody taking manual actions there. Let's look at what are the main benefits of predictive maintenance. It can drive higher customer satisfaction ratings. Besides the cost aspect, this is probably one which is most important for your business. When you set the right expectations regarding day, time, and length of an intervention, the customer can plan their involvement. The same goes for the duration of the outage. The customer can prepare. You can already take actions before the downtime if you have predictive maintenance in place, if you know when it's going to take place. When analyzing historic data, you find the service trends for each service location. Your customers are spending less time calling, contacting you for emergency interventions. You will have managed to take their needs into consideration and design a schedule that fits just for them based on the input received. Without their interaction, you can improve the service for them, which is a huge improvement for every company if they have a supplier which can provide this type of service. There are a large amount of benefits. Let's look at some most relevant which we have identified. Already said, customer satisfaction, as well thanks to operational stability, avoiding unscheduled downtimes, increasing engineer/technician utilization, reduction of maintenance costs, enhance the asset and equipment lifetime. And you can ultimately as well improve machine utilization. Let's go through them one by one and look at them in detail. With more stability of the assets, which you are monitoring through your predictive maintenance, the customer is not affected in his work, in his production, in his delivery, which can easily lead to an increase of 10 to 20% in customer satisfaction ratings. This has a huge impact, which you only see over time, because the customer, when you get to them and when you ask them about their customer satisfaction, they will recognize, well, compared to the last time frame, we just had less interventions. Big improvement there. Due to the early engagement and proactive service approach, downtimes can be planned ahead of time with a minimal impact on the customer. You can put it to late shift, you can put it maybe even during the night, or you can put it on weekends if you know that there is a downtime required due to the data you have gathered. With less emergency interventions, engineers and technicians can be utilized more efficiently, and and the not critical work is scheduled as part of their regular activities. Remaining with the example of you take action, you plan a maintenance out of the regular schedule, but still in accordance with the customer timelines. They don't have any downtimes. They don't suffer on any unplanned outages which they cannot work. Preventive maintenance is executed on preventive maintenance is executed based on fixed intervals. With predictive maintenance, the costs can be reduced by 15 to 30% because the work is only performed when it is required. Meaning you don't go there if everything is within its limits. You don't go there when there is nothing to report and you just do routine maintenance. You can push that further out. You can increase the maintenance cycle because the work is only performed when it is actually required. When a failure occurs, this always brings the risk of structural damage on an asset. Due to timely performed maintenance, the lifespan can be extended. If maintenance is not carried out in the right way, or if it is carried out too late, this can have a long-lasting effect on the asset, on the device, whatever is under contract there. And with that, you extend the lifespan of these devices significantly. Lastly, the machine utilization can be improved between 2 to 5%. By avoiding unplanned downtimes, you can make sure that the downtime which needs to take place because something is maybe worth to check or worth to exchange, you can reduce that downtime to a minimum. The machine is longer available for the customer. If you can move out preventive maintenance, then this means as well less downtime for the customer. That makes predictive maintenance so important and makes it so valuable for any customer. Let's talk about how you can implement and benefit from predictive maintenance. As highlighted before, IoT integration is the key technology to deliver predictive maintenance successfully. How is IoT defined? The Internet of Things allows computing devices, mechanical and digital machines to exchange data without the need of a human-to-human or a human-to-computer interaction. What do we mean with human-to-human and human-to-computer interaction? You can define me being a customer, me being a user, and I do have an issue on my machine. Something is not working right. I need to call the service, and I'm calling the service hotline where another human picks up the phone. This is a classic human-to-human interaction. I am a human. I am talking to another human on the other end. They take all the data. They take all the information. They may perform additional troubleshooting, whatever is accurate, and they will then initiate service events or whatever is required. A human-to-computer interaction is defined as me again being the human, seeing something is not working, calling to the help desk, calling the support, and a machine is picking it up and is taking all the data from myself. Alternatively, I go into the web, I fill in a support form. That is as well a human-to-computer interaction. For predictive maintenance and for IoT, we want to enable computer-to-computer interaction. Not I need to see that the machine is not working. The machine recognizes it itself. It recognizes either the issue itself and can report on it. That's with the example of printers. They usually do know very well what is happening. Or you install a set of sensors which initiate a constant data flow. And this constant data flow shows to the customer, shows to the service company, what is the status of the machine. And out of that data, you can then take all the actions. You can go ahead and do any kind of analysis and decide then what kind of service is required. So with that in mind, the first step to go ahead and to implement predictive maintenance successfully, the first step is to collect the data in order to assess the probabilities of failure. Gathering more meaningful data allows you to predict issues and to make better decisions for your clients. When you're using a smart solution like Fieldcode, you will not only know that there is some action required, but you will know also what exactly requires your attention. And you need to filter out the so-called white noise. There are hundreds of thousands of events being generated every day. The data is a never-ending river of information. Which one is the relevant information you are looking for? You need to go and you need to have a system which supports you in looking at all that data, looking at what is okay, what is acceptable, and where do I see deviations. With temperature, with humidity, whatever you want to analyze. If you check the speed of a machine, whatever you want to analyze, it constantly produces data, and it constantly sends this data to you. Depending on the setup, it might be every second, sometimes even multiple times per second, or it may be only every 10 minutes. Depending on the amount of machines you're looking after, this is a huge amount of data. Nobody today needs to sit in front of a PC, of a dashboard, and look at it all day long. Machines do that on our behalf. Machines take different data into consideration, putting one information, temperature, next to the open or closed status of a window. So this is what you need to filter out and to only look at the relevant data. You still have everything tracked for troubleshooting purposes, but you don't want to look at it constantly. For example, a sensor which measures signal strength can recognize completely autonomously when the signal is getting low. But it will only create an event if this is a continued issue. Based on predefined thresholds, it may accept 1 or 2 low responses. Only when the threshold is hit, the intervention will automatically be created and an unplanned maintenance can be fully automated, dispatched to an appropriate on-site resource. The machine takes care of itself. It communicates to another machine, which then interacts and which then sends out resources to fix the problem. Fieldcode provides you exactly with that link between the monitoring of your data and the automated ticket creation. Meaning you don't need to follow manually the workflow, but it is fully automated. Based on given thresholds, a ticket will be created and it will then route it based on skill set, based on availability, based on location, whatever you want to take into consideration, it will be routed to the adequate engineer or subcontractor of your choice. While this is happening without any input from the customer, you can then go proactively and inform your customer, keep them informed throughout the intervention about the status of it. This, as I mentioned before in the section of the benefits, this is a game changer. If you go to the customer and tell them, hey, we have recognized something is not working as expected, but don't worry, we already have here the fix. We already know the engineer will be on site within 30 minutes and it's going to be fixed within an hour. Your users will not even recognize it. This is a game changer when you talk to a customer and you can provide that benefit to them. It doesn't matter what IoT sensors are in use. Through standardized interfaces, almost all sensors can be connected. In order to get started with your implementation, you need to define a scenario in which you want to apply predictive maintenance. You need to define what is it we really want to look after. Based on that, you can then start the purchasing process and buy and install the set of sensors which is required to achieve that scenario. Through standardized communication protocols, there are many out there, LoRaWAN, one of them, sensors communicate with their gateway, which then is connected to the Fieldcode IoT dashboard. Once the data flow is initiated, once the data is in Fieldcode, it can be trained on the relevant thresholds to decide when an intervention will become relevant. Using these real-time IoT feeds, Fieldcode generates their automatically tickets when needed and already before an actual outage occurs. It can create tickets with different priorities, with different severities based on the data which is received, based on the criticality of the machine. If you have a redundancy, certainly it won't be that critical as if you have a machine which is in the live production environment and it is the only one without a failover. So the system can recognize that, and based on the upfront set values, it will determine who is the best resource to go there and what is the best time to take action. With the fully automated FSM capabilities, Fieldcode will then assign the right resource. It will include the intervention in the optimization routine to deliver the service most efficiently. In Fieldcode, we are using our Fieldcode optimizer, which takes into consideration all the workload for a given day, for a given week, taking into consideration latest service delivery times, availability of resources, availability of parts, where do the parts need to be picked up, and so on and so forth, and puts the ideal schedule for your workforce in place. It calculates the routes. It avoids that multiple engineers are driving into the same direction or maybe even meeting at a customer. You can even automate spare part ordering. Tickets will only be assigned once to the engineer once the required parts are available, once they can be picked up, once they have been delivered to the customer, whatever might be the scenario. This is the advantage of advanced field service management and spiced up with IoT and predictive maintenance. We have found with customers that the automation and optimization can increase the productivity of your field workers by up to 40%. That comes due to the fact that an automated route planning helps drastically to achieve better and more efficient schedules for your field workers. As mentioned before, if you take that into an automated level, you can constantly, throughout the day, whenever your work is flowing in, you can revisit the schedule and you can adjust it and optimize it all day long. For the full service process, you need to consider your field workers require the right tools. And one important tool for them is information and the access to the same. The mobile application of Fieldcode reduces the manual input to a minimum and it guides the engineer through the intervention. It provides all historical information about previous jobs. It provides all information which has been gathered through IoT and being used for the predictive maintenance. It builds the foundational knowledge for each on-site intervention. With the full overview, technicians can be more helpful and they can increase the first-time fix rate due to better data being available for their troubleshooting. When they come on site, ideally, they already know what is the problem, what is the most likely spare part I'm gonna need. Is there any other action I can do, I can perform on site in order to get the system up and running in no time? So with Fieldcode, you can not only automate the process of receiving information, you improve your overall service delivery with predictive maintenance. And you can streamline your delivery processes, automate them all the way up until the last mile, up until you have to go on site and you have to just do the work which the machine supports you with all the information. Let me give you just a quick overview for everyone who has not yet worked with us before. Fieldcode Field Service Management Solution is developed since more than 20 years. And we got more than 10,000 active users all around the globe. Fieldcode is being used in more than 100 countries and is provided by our team, which consists of more than 100 colleagues located in 6 different subsidiaries. You see on the list below, we are headquartered in Nuremberg, Germany, but we have a couple of European entities. So we have been growing out of Germany into Europe and as well have an entity in the US. So wherever you are located, we are happy to support you with our helping hands of the customer success and support department. One segment which already makes use of predictive maintenance heavily is the elevator industry. We just have released a use case for the elevator industry, which I would recommend to you to have a read through to get an idea of how all this works in practice. Many of the strategies which you find in that use case can be adopted to other industries as well. They are uniquely applicable not only to the elevator industry, but to every service heavy service requirement business. Wherever you have assets, wherever you have devices which are under maintenance, you want to go from preventive to predictive maintenance and make a difference to your customers and to your service workforce. So we, as mentioned before, we have reserved some time for your questions. I see some have already been raised in the chat. Let me just go over here and bring up the first one. It was raised here. What IoT protocols do you support with your application? Well, it doesn't really matter which IoT protocol you're using. You are always using a gateway which needs to be connected to the internet. Through secure communication, the data will then be transferred to Fieldcode. Use whatever protocol is appropriate for your use case. There are different advantages, there are different downsides. If you're talking about CoAP, MQTT, Zigbee, even Wi-Fi can be an appropriate protocol in some instances. It depends if you have permanent power available. So that is something where we are happy to help you when choosing for a solution if you have not yet installed one. But it doesn't really matter which protocol you are using, because we can support all of them. Then we got a second question, which is here. We are using Business Central to manage all our assets. Can this be connected and still be used as the primary tool? Yes, of course it can. Fieldcode can be connected through standardized APIs to basically any kind of ERP or CRM systems. If you are using Business Central, so Microsoft Dynamics, probably Dynamics 365, this has standard API capabilities. We can talk to this. There is a very easy way to connect Fieldcode with any kind of these systems. So yes, if you're using an ERP system where you have all your all your devices, all your assets already tracked and already managed today. You can continue to use that. You can use any CRM system if you want to create tickets out of there. Of course, you can use Fieldcode to create tickets, but very often you have your data in a asset database anyways, and you probably want to connect it to Fieldcode. Not a problem. Good. Any other questions from any of the participants? I don't see one now. Good. Then let me just make you aware. If you want to talk to us, if you want to see the tool in action, if you want to have a personalized demo, please feel free to reach out, demo@fieldcode.com, or you visit our website. We have brought up just a pop-in where you can visit immediately the demo site, where you can pick from a calendar very conveniently your date and time to see the application in action. Reach out. We are more than happy to support you. We are more than happy to provide you with an overview of the tool and to discuss with you what is your use case, how can you benefit best from our solution. And with that, thank you very much for your participation. You're going to receive an update with a recording of this session if you want to pass it on to colleagues, if you want to pass it on to anybody who was not able to make it today. But I hope to speak to you soon and want to thank you very much for your attendance. Take care and goodbye.